Okay, so do you remember we started talking about how to find the derivative of functions? I talked to you before that what was the derivative? Assume that you have a function called f of x, and then you have a point in the domain of that function. Yes? So this shouldn't be confusing. This means a belongs to the domain of the function. If you have forgotten about the domain, for example, if I have f of x equals to x squared plus 2, what is the domain of this function? The domain is all possible values that you can choose for the input of your function. Okay, so here I can choose whatever I like. Do you agree? There's no restriction here. So the domain of this function, for example, is the set of all real numbers. On the other hand, for example, if I have f of x equal to 1 over x, I can choose whatever I like for the input except one single number, and that number is 0. I cannot choose 0, yes? So it means that the domain of this function is every number except the number 0, yes? Something like that. So this shouldn't be confusing for you. So when you want to talk about the derivative of a function at a point, the first condition is that that point should be in the domain of the function. So for example, if I give you this function, f of x equal to 1 over x, I am not allowed to ask you calculate f prime at 0, because 0 is not in the domain of the function. So that is what I just want to mention here. So if you have a function, and if you have a number in the domain of the function, then you calculate this limit f of a plus h minus f of a divided by h. H goes to 0. Yes? If this limit exists, then the name of this limit is the derivative of the function f at point A, and there is a symbol for that. You denote it by this symbol, f prime of A. So if that's the case, then I would say that the function is differentiable. Oh, sorry, I will talk about that later. So this is called the derivative of the function if it exists. Yes? I think I did some examples of this, actually quite a lot of examples using this definition, and then so far you have this experience that usually calculating this limit to be able to answer the derivative of the function is actually tedious. So then next, in the previous session, we come to this conclusion that it would be better if we try to find this limit for famous functions and tabulate them, and whenever we want to, whenever we need them, we can go and refer to the table and use them. Yes? Okay? And then with that, the problem was that there are infinitely many functions in mathematics. So the first thing that we can do is probably the most natural thing to do is to categorize the functions into different types and learn the derivative for each different category so that we can use them. Otherwise, this is useless. There are infinitely many possibilities. Yes? Okay. And then I told you that here it is better when we want to deal with this part, it's better to replace a with x. Yes? So, and the only thing that I have done here is that I have written f prime of x. X is still in the domain of the function, is the limit. You will see why this is better. F of x plus h minus f of x divided by h, h goes to 0. So from now on, we want to use this formula over and over again. And then I put a table here and try to complete this table. Okay, so here I will have f of x, any function here, and then its derivative here. So do you remember what was the first one in our list? Do you remember what was that? Yes, a constant function. So if I have f of x equals to c, and let me write here, c is a constant, then its derivative, what was the derivative? Do you remember? Yes? Yeah. It was 0. Yes? And then the next probably function would be f of x equal to x. I don't know, do you remember what we did for f of x equal to x? We calculated it, that one, yes? Am I right? Did we calculate the derivative of f of x equal to x? No? Okay, so let us calculate that one. So here, my question is that f of x is equal to x. My question is that what is f prime of x? Okay. Okay, so what should I do? I have the formula in front of me, so I would write f prime of x is equal to the limit. Okay, I have a fraction, h in the denominator, h goes to 0. Okay, what can I write instead of f of x here? Just look at the problem and just talk to me. What's f of x here?
X.
X. So we put x here. But can you tell me what can I write instead of f of x plus h as a whole? Remember, there is no product here. F is a function, x plus h is playing the role of the input of that function. So what would be f of x plus h in this case? Yes? No?
X plus h.
X plus h. Let me just repeat it once more. So you see, f of x is equal to x. What does it mean? It means that this function takes the input, you call it x, from you, and it gives the input back to you. Yes, you see, by looking at this function, you need to interpret this formula in this way. It takes an input, call it x, it will return back the x itself. Now the input is x plus h, so it will return the input back to you, yes? So the input is here, is x plus h. Let me know if you don't understand this here, okay? Is that clear? Yes? Okay. And then now you see minus x and x are cancelled. So what's happening? It becomes the limit of h over h goes to 0. But then h and h can be simplified. Because h goes to 0, h is close to 0 but not equal to 0, so I am on the safe side to divide by h, so it becomes 1, h goes to 0. But that is a constant. I am considering not the values of this constant function when h goes to 0. But when the function is a constant, it doesn't care about h at all. So the limit is 1. Okay, now I can clean this question mark and I can write 1 here. Okay, so that function is the derivative of x is simply 1, yes?
Why didn't you write c minus c?
No, this is not c because in the previous case that I wrote c minus c, my function was f of x equal to c. That's a different function. If you want, I can repeat that, but we finalized that in the previous session. We'll realize that for this function, if I do the same thing, the answer becomes 0. Now, in this lesson, I am considering a new function, which is f of x equal to x. And then I calculate the same formula, but for the new function. This time I got 1 instead of 0. So the answer in front of it would be a 1. Yes?
Mm-hmm.
Okay. But let me exactly follow these pages of the book. Now, let us increase the level of difficulty of this function with respect to the with respect to the degree of this polynomial. Let us increase the degree to 2. Here, the exponent is 1. Let us increase it to 2. Let us see what happens. So it means that I want to do the same process, okay? But I want to change my function. Instead of having x, I want to have x squared this time. Okay, so let us see what happens. That's exactly the way that the book has written. That's a good way because in general you need some formulas that you don't know yet. So the question is this. If I make the function a little bit more difficult, say x squared, and ask the same question. So what is this? What is the derivative of this? Okay, let me tell you something. Here, I had a constant function. Its derivative becomes a constant function 0. Yes? So don't say that this is number 0. So you see, f of x, if f of x is equal to c, we learned that f prime of x is 0. This is not a number, this is still a function. I will talk about that a little bit later. And now we realize that if I have this function, the derivative of this is a constant function. But which constant function? The constant function equal to 1. Yes? Now let us think about this new problem. Okay, I have the formula here, so I don't rewrite it, but I will use the formula to calculate for this one. So f prime of x is equal to the limit, okay, and then I have h goes to 0, and then, okay, now you can help me. So let me get rid of this. Okay, now tell me, what should I put here? Here is f of x. F of x in this case is x squared. So what I write here is x squared. Okay, but I want to make sure that now you understand. Can you tell me what should I put here? F of x plus h.
X plus h squared.
X plus h squared, yes? You would say that this function has this role. It takes an input from me, it squares it, and give it back to me. Now I am giving x plus h as the input. So it will do the same thing for this new input. It square it, and it gives back to me. It give it back to me. So it becomes x plus h to the 2. Just look here. If the function was x, it means that the exponent was 1. Okay? So what happened here? I had a power of 1 here, and I also had a power of 1 here, so I didn't write it down. But when I write x squared, then I have power of 2 here, the power of 2 here. So it means that the problem becomes a little bit more complicated when I increase the exponent. Yes? But it is very simple and we can do that. So what we can do, we can calculate this in this way. I know the quadratic rule, so I use it to expand this, the first one to the 2 times the first one times the second one, plus the second one to the 2, and then I have minus x squared. And then I have divided by h goes to 0. Yes? And then you see that this x squared and that x squared are cancelled. And then what is left for me is the limit, let me write here, yes. The limit 2xh plus h squared divided by h goes to 0. Okay, now talk to me. What should I do for calculating this limit?
Factorize.
Yeah, just say it, yes, factorize. Factorize means taking h out. So what can I do here? It becomes the limit h, and then I have 2x plus h divided by h goes to 0, and then this h and that h are cancelled. So this becomes the limit of 2x plus h goes to 0. I don't know if you remember, in the first chapter we talked about the limits with more than one variable. So we were preparing ourselves for this case. So h goes to 0. So it means that you don't need to be worried about x. H is getting negligible. So it means that the answer to this would be, what's the answer? 2x. So now it means that we can answer that question mark. So the question mark here is 2x. Okay, so let me write this one, because the point is that we need to find a pattern. Of course, finding a pattern is not a rigorous mathematical way of doing, but if I want to prove it in general, it needs something that you don't know, okay? It's a very long story, okay? But at least you see that the derivative of x is 1, the derivative of x squared is 2x. To realize the pattern, I'm just following exactly the book. Let me calculate for another power, yes? So let me calculate this one for x to the 3, okay? I can clean this one now. So the question is now this. I have this function, and then you see it becomes a little bit more complicated. X to the 3, and the question is that what is f prime of x? Okay, I have it here, so f prime of x is equal to the limit. Okay, so I have h goes to 0, I have h here, minus sine. F of x is x to the 3, so I put x to the 3 here. I hope that you don't have any problem saying this one now. What is the answer here if my function is here? What should I write here? Yes?
X plus h to the power of 3.
3, exactly. So I make sure, please, if you don't understand this, please let me know. Okay, now you see that why the problem becomes harder and harder. Yes? In the first case, I had powers, exponents were equal to 1, so I didn't do anything, I just simplified. In the second case, this exponent becomes 2. But that's not a big deal because I know the formula for the second power. For example, there is another formula for the third power, there is another formula for the fourth power, and there is a general formula for any nth power when n is a natural number, and that's called binomial, Newton's binomial theorem, okay? Theorem. What does it mean? So it means that if n belongs to n, 1, 2, 3, 4, 5, etc., actually Newton, or Pascal actually, invented a formula for a plus b to the n. Okay, but this is not at the level of your course. You will study it in Math 5 if you want to have it. But because we don't know that formula, we need to do it case by case and try to see a pattern going on and try to guess that one and ask your teacher, is pattern correct? And your teacher would say yes. If you want to see why the pattern will work, you need to wait until you see this formula, and if you're interested, come back and try to prove that, okay? But the idea here is try to find a pattern. Okay, let me calculate this one for you. In one of the exercises, level 3 problem in the book, they also have asked to calculate it for x4. Okay? But by the way, do you really need a formula or not? Assume that you don't know the binomial theorem. Do you really need a formula for this? So that if you know the formula, it is easier. But do you really need a formula? Yes?
No, we can just do x to the power of 2 times.
X plus. And if I have x plus y to power 100, in principle, I can multiply it 100 times, yes? So in principle, I don't need a formula. But of course, don't underestimate this. If you have x plus h to power 100, it means that you have 2 to power 100 terms. And that's a very, very big thing, yes? Okay, so, but anyway, the idea, I want you to understand, even though we are not going to address the question here, but if somebody asks you why the calculation becomes harder and harder, there's the answer to this is that because expansion of this becomes harder and harder. Okay, but other than that, otherwise we don't have any big problem here. I don't know, there is a formula in the formula sheet, always you see it, but might be you don't use it. So let me first convince you of that formula. So assume that I want to expand a plus b to the 3. So as Kevin said, I can write a plus b to the 2 and then multiply it by a plus b. Agree? That's the meaning of a plus b to the 3. But we know that this one is a squared plus 2ab plus b squared, and then I have a plus b. Okay, so let me multiply it now. So what happens? It becomes a to the 3 plus a squared b plus 2a squared b, yes? And then you have 2ab squared, and then you have b squared a, and finally you have b cubed. But you can simplify that. A cubed and b cubed cannot be simplified, so let me write a cubed here and b cubed at the end. But then I have 2a squared b and 1a squared b here, so it becomes 3a squared b. And then I have what? ab squared and 2ab squared, yes? So it becomes again 3ab squared. So that is the formula, so let me write it here. So I have a plus b to the 3. If you want to read it, it becomes the first one cubed plus the first 3 times the first one squared multiplied by the second one plus 3 times the first one multiplied by the second one squared, and then finally you have the second one cubed. Yes? So that's the formula. You don't need to memorize that. It's in the formula sheet. but you understand what's going on, okay? So I can use the same formula to expand this. The only difference is that now x is playing the role of that a and h is playing the role of that b. So let us see what happens. X to the 3, the first one to the 3, 3 times the first one to the 2 times the second one, 3 times the first one times the second one to the 2, and finally the second one to the 3, and then I have minus x to the 3, and then divided by h goes to 0. Yes? Now you see that this x to the 3 and that x to the 3 are cancelled. Okay, let us do it a little bit faster. So do you know, you have a little bit of experience now. So what is the next step in your head? Imagine that they are cleaned. So what should I do? Factorizing what? H, only h, yes? Because this is the highest power of h which is in common. So I can just take h out, and then it is 3x squared, and the next one becomes 3xh, and the next one becomes h squared, and then I have to divide this by h goes to 0. And then this one and that one are cancelled. So, and then what is the answer now? If I send h to, assume that this is not here, this is not there, h goes to 0. This doesn't depend on h, so it's not affected. But this one becomes 0, that one becomes 0. Yes?
The answer becomes 3x squared.
Yes. So the answer becomes exactly 3x squared. Yes? So if I put it here, okay, it becomes 3x squared there. Now let us write this in a slightly different way so that we can use these three to figure out the pattern. Okay? What is the exponent here? I haven't written it down, but you know that the exponent is 1. Instead of, so let me write it 1, and do you agree with me I can write it like this? Okay, the reason that I am making it a little bit complicated because I want you to compare these so that you can come to a pattern. Yes, so you see when, oops, what is this one? Okay, so here x to the 1, when the exponent was 1, 1 is here, and this exponent becomes 1 less. It's 0. When this was 2, the same 2 you see, it appears here, but the exponent is now what? 1. It is 1 unit less again. And if I go to x to the 3, this 3 is here, and this exponent is 1 unit less 2. Yes? So, what happens, so what is your rough guess? If I have x to the, I will complete it later. If I have x to power a, but if a, so let me write c is a constant, yes? So, but of course for the time being, I have only considered natural powers, 1, 2, 3, yes? Assume that this c is natural for the time being. And then, can you guess the pattern for x to the c? Yes?
X times c to the power of c minus 1.
No. X times
C. To the power of c.
No, c times.
Yeah,
C times x. Is it the same?
No. C times x to power c minus 1.
Is it? Oh, okay.
Yes? Because now what you see, c is supposed to go down, and then you write x to the power 1 unit less. Yes? So that is the pattern that we discover only for natural numbers. But now look, the problem becomes very hard. This innocent problem is a very hard problem actually, not that easy. Because the Newton's formula only works when n is a natural number, 1, 2, 3, 4, etc. But these are not the only powers, yes? I can have a negative power. I can have x to power minus 2 and ask the same question. So, can you tell me if I have x to the power of negative 2, what will happen here? It becomes x plus h to power negative 2 minus x to power negative 2. But x plus h to power negative 2 has a different story. You cannot just simply write it with that one. If I want to have x plus h to power negative 2, I need to write 1 over x plus h to power positive 2. and then I can use the expansion. But the problem becomes harder because these are again fractions in their own term. Yes, so this expression becomes complicated and complicated. Yes, and then this is not the only problem. Another problem is that what happens if I have x to power 1/2? Then I don't have any expansion at all, a finite expansion. So it means that this would be 1/2 x to power 1/2. I need to find out another trick. Yes, we will talk about these two cases. This is the way that the book has done it. Okay, and then the other problem is even harder. What happens if I have x to power square root of 2? So just I want to mention that if you want to solve this very simple formula very clearly, so very completely, you have to do a lot of work. You need to address the question for these negative powers, fraction powers, irrational powers, and then you are done. But the good news is that if you do all this hard work, all of them follow the simple rule, the same simple rule. Okay? So that is, this part, at least I gave you some idea for natural powers. I will try to give you some idea about negative power and this fraction power to make sure that at least for these cases, this pattern still follows. But the complete solution to this problem is left for the university, okay? So let us continue our expedition, yes? So this so far was our rough guess. Now let us talk a little bit about negative power and fraction power. These are the two examples in the book as well. So let me ask you this question and then finalize this problem. I want you to see what are the difficulties here. So assume that this time I have this function. F of x is equal to x to the power of -1. Okay? And then I want to ask the same question. What is f prime of x? Okay, can you tell me if this follows the same pattern, what should be the answer at the end? We don't know yet, but assume, I am telling you, assume that this one also follows the same pattern. What would be your expectation for this question mark here? Yes?
-1x or minus x to the power of
Yeah.
-2.
-2, yes.
Okay.
Exactly, yes. So it would be -1, as you said, and it is not necessary, you fixed it that, to the power of -1, which is my exponent, minus another 1 because of the formula. If it is going to follow the same pattern, this is the answer that you expect. Yes? So let us simplify this. What can I write instead of this expression? X to power -2. And instead of writing -1 times this, I can simply write minus there. If I follow this rule for this function and I get this answer at the end, it means that, yes, this function also follows the same pattern. Yes? Let us check. And then you see that why the problem becomes a little bit harder. So, if I want to calculate f prime of x, this becomes the limit. Instead of, let me write everything, minus, you have enough experience now. So minus, what can I write instead of f of x is x to the -1. Okay, can you tell me what should I write here immediately? Come on. Are you sleeping?
X plus h minus 1.
Yes. I don't know why do you hesitate, yes? Yes. You can save my energy. Okay, so that's the case. But now tell me, what should I do? Is there any rule for expansion to power -1? No. So what can I do to simplify this if I want to?
1 divided by x plus h.
That's the only thing that we can do. The definition of a negative power, yes? So it becomes equal to the limit of 1 over x plus h to power +1, which I don't write it, and for the same, I can do the same for this. So you see the question becomes harder. Now assume that instead of -1 you had -3. Then it becomes this 1 to power 3, but this itself is that complicated relation. It's now in the denominator, so it becomes more complicated, yes? And then I need to simplify this. And now you need to remember what I told you in chapter 1 to simplify this rational expression, yes? So you need to take the common denominator between these two, and then you do the division, yes? So you see, whatever we talked about in chapter 1 is very important, and that's why I spent so many time on it. Okay, so this becomes the limit. I have this h here. What I have here, the common denominator between these two, the LCM, least common multiple, is this. This one, I divide it by that one. It is x times, I multiply x by its numerator, it becomes x. I have a negative sign here. I divide this by that one, it becomes x plus h. I multiply it to the numerator. But if I write it in this way, it is wrong because I need to keep it in pair of brackets. H goes to 0. Okay, so let us simplify this. The first step, I need to open this pair of brackets. So this becomes the limit x. This minus sign goes for x and it goes for h. It becomes minus x minus h. But let us don't touch the denominator. And then you see that this x here and that x are cancelled. And then this becomes the limit. Minus h is there. So let me write it here. Minus h is there. I have x times x plus h here. And I have another h here. So do you remember, this h is h over 1. And then you are supposed to multiply these two numbers which are far away from each other and put it in the numerator. So this becomes minus h. And then I am supposed to multiply these two numbers which are close together and put them in the denominator. So it becomes x, h, x, x plus h. H goes to 0. And now you see that this h and that h are cancelled. So what is left for me is the limit. In the numerator is minus 1. The denominator is x, x plus h. And h goes to 0. Now, when I send h to 0, what will happen? It becomes minus 1, x times x plus 0. But x plus 0 is just simply x. X times x is x squared. So it becomes minus 1 divided by x squared. But do you agree that this follows the same pattern now? Because minus 1, x to the power of 2, if I want to write it with negative power, minus 1 is up there. I take it to the numerator, and I need to make the exponent negative. But that is exactly minus x to power minus 2. And that is, so it means that yes, for this function, we also have the same pattern. At least you have some idea. If I have negative powers, the problem immediately becomes harder because you have fractions involved in the numerator. Yes, this is the only thing that I want you to understand. But by the way, in this course, I teach it in complete. I want you to completely understand. But the questions in the exam are much simpler. I have a function, and you will see what would be the questions in the exam. Okay. But this is very, very important to understand these things if you want to continue math, or if you want to go to a technical university. There is no escaping from these things. So it's better to understand them here, okay? Okay, so this is one of them. And the next one that I want to talk about is, at least I want to familiarize you with the notion of fraction powers. For irrational powers, forget about it for the time being. We will come back to it at some point. But let me talk about this function now. Then I want to ask you again, if I clean this minus 1, and put it 1 over 2, can you tell me if it is going to follow the same rule then what would be your guess for the derivative here? What would be your guess? If this follows the same rule, the rule tells you that bring the exponent down. So the exponent is 1/2, so I need to bring it down. And then I need to write x to the power 1/2, your exponent, 1 unit less. Yes? If it is going to follow the same rule, the answer to this that you would expect is this one. Yes? But let me simplify this. This becomes 1/2 x to power minus 1/2. I can simplify this 1/2 x to power 1/2. So apparently, if this is going to follow the rule, this should be the answer to the function, to the derivative of the function. Let us check that. So I want to answer this question. What would be the difference? Instead of -1, I will have 1/2 this time. Yes? Agree? But none of them will remain the same, so I clean all of it. So you see, the problem becomes completely a new problem. I couldn't just change a little bit and say that this is the answer to that one. This is why this problem is hard. When I change the type of the exponent, the way that I solve the problem becomes completely different. Okay? But the good point is that all of them follow the same rule. Yes?
Does this have a proof? Because this doesn't prove anything.
No, it doesn't prove. Yes, it has a proof.
Yeah.
But the problem is that I told you, the proof is not at the level of this lesson. Yes, that's the one. But at least doing these things case by case will teach you what are the problems there. So you see that for low values of n, like 1, 2, 3, we can expand that. But when it goes higher and higher, we need a theorem to be able to expand it systematically. When it becomes negative, then you see that these go to the denominator, makes the calculation harder. Now, at least you can feel it, why it becomes harder. That would be enough for this course. And then now I am just giving you another type of this, which is a fraction one. And then you see that the solution is quite different. But the good point is that the answer follows the same rule. Yes, the proof is hard, even for this, the general proof. And the general proof, by the way, is not one proof. It's case-by-case proof, but in general. So you say that for any natural number, this is the proof. For any negative natural number, this is the proof. For any fraction power, this is the proof. And for any irrational number, this is the proof. But here I am just talking about one fraction. If you want to go higher, then you talk about all fractions. Okay, how can I solve this problem now? I want to calculate this limit. So you need to remember what I told you in chapter 1 about calculating this kind of limits. Now you know it, but probably you have forgotten what, yes?
Conjugate pattern, yeah.
Yes, exactly. How do you realize that? Because 1/2 is another name for a square root. Yes, so let us write square root here. It's more familiar for us. So this becomes a square root of x plus h minus a square root of x divided by h. And as Martin said, we use the conjugate pattern. So I think you remember the conjugate pattern if I have a square root. So what was the rule? I need to write the same expression exactly, so, and then multiply, rescale it by the conjugate of the numerator. So the conjugate of the numerator, x plus h plus a square root of x divided by the same expression. Yes? So you see, the solution is completely different. The previous one for negative powers, I just used the negative one, but the solution becomes different. And then, by the way, you realize why this problem becomes harder and harder. Assume that I make it 1/3. Then what will happen? This becomes 1/3, 1/3. Then this becomes the third root. But the third root cannot be removed by conjugate pattern. There is another pattern going on. And if I make it 1/4, there is another pattern going on. There is a general pattern for all 1/n powers. This is why I want you to understand why the problem becomes harder and harder. Okay. But this is not that hard. So let us, oh, I forgot to not to clean this anyway. So then this becomes equal to, let us do it a little bit faster. This one multiplied by that one is the conjugate pattern. So it becomes the first one to the 2. This one to the 2, the square root sign will go away, yes? So this becomes x plus h minus the second one to the 2. A square root sign will go away. So it becomes minus x. And then divided by this multiplied by that. H goes to 0. But now this x and that x are cancelled. So what is left in the numerator is just h. And then I have h square root of x plus h plus square root of x. H goes to 0. And now this h and that h are cancelled. So I have 1 in the numerator. Square root of x plus h plus square root of x. H goes to 0. So what would be the answer now? I need to replace h with 0. So what happens? It becomes 1 over square root of x plus 0 plus the square root of x. What's the answer? X plus 0 is just x, the square root of x, another square root of x are combined, so it becomes 2 square root of x. So the answer is 1 over 2 square root of x. And that was the exact, if you remember, that was exactly what I wrote there. Okay, so let me change the form that you can feel it, okay? This is the answer. So this becomes 1 over 2 x to power 1 over 2. But then this becomes 1 over 2 x to power minus a half. But minus a half can be written as, of course this is the end of the problem. I just want to see that this is following the same pattern. So look here, the answer to this, 1 over 2 goes down. And then what I have x to power 1 over 2 minus 1. Yes? So that's exactly the same pattern. So now, if you don't mind, there is only one thing that I haven't talked about at all. For example, what we can do about this. But this also follows the same pattern. Okay, so let me clean everything here and just write one single formula. So you don't need that many formulas actually. So the second one is x to the c. I emphasize c is a constant. Okay, the derivative becomes c x to power c minus 1. So you see I have written a constant. I haven't mentioned is it natural, is it negative, is it fractional, is it rational. It's always true, okay? So x to the c, the rule is very simple. Just bring it down and multiply it by x to the power of c minus 1. Okay, but my point is that I want to write something here with green. I want you, this is the only one given in the formula sheet. Okay, if I ask you about x, you don't need to memorize. You can use the formula, but you will be a little bit slow. But what was the derivative of x quickly? Do you remember? 1. It's better to remember it separately. I really recommend you to do that, okay? And then if I have 1 over x, you remember we talked about this, it becomes minus 1 over x squared, and especially this square root of x. Square root of x is very important. So if you use it in my exam, I agree with that, so I give you the marks, okay? But in principle, you need to not to follow this. You need to say that if you tell me square root of x, I write it x to power 1 over 2. I bring 1 over 2 down. I would write this one minus this one. Then it becomes x to power minus a half. Then I take it to the denominator. It becomes positive. Then I write it like this. Okay. So every time you have to do this process. So of course, if this is the third root, I do the same process. But at least this is a very famous function in mathematics. So this thing that I have put in green here, you don't need in principle to memorize separate formulas because all of them can be calculated using this single formula. But this is my advice, because these are very happening in mathematics, it's better to remember them separately, or at least try to remember them separately. Is that clear? Okay, so what I have written here are special cases. So let me write special cases. Important special cases. Is that clear? Okay. So let me give you some examples. So let me emphasize here that this is a constant. Emphasize here that C is a constant. For example, I cannot ask you to calculate the derivative of this function. Yes? Because the exponent is not a constant. You need to wait for university to know what would be the derivative of this function. Okay, so be careful. It's very, very important. If I ask you this and you say that x goes down, and then I write x to power x minus 1 following the same rule, that is totally wrong. This formula is only working if the base is x, only x. It's very restricted. And the exponent is whatever you like, a constant. Yes? If that's not the case, if it's not exactly this, we are not allowed to use the rule. Is that clear? Okay, now let me give you some examples. I don't know which example because the examples are very trivial, yes? So, example. This is a very important example even for the exam. Okay, so you might think that, okay, how this could be interesting. This can be really interesting. We will come to that. Okay, so let me write this. Determine the derivative of each function. Okay, so let me start with very, very simple one. So I will give you f of x equals to x to the power of 7. I want to take the derivative of this function. I don't need to go through that very tedious process of calculating limits anymore, because this is a famous function. We have it in our table. We just use the formula in the table. And I really want you to start memorizing them. It's not that hard. But anyway, you will get the formula sheet. So what would be the answer to this? Can you tell me? Let us do it patiently. F prime of x, the derivative of this function, is equal to what? 7 goes down. By the way, let us repeat this. Can I use that formula for this? The answer is yes, because the base is exactly x, nothing else, and the exponent is a constant. So this is valid. I can use the formula. The formula tells me bring this down, and what to do? The exponent becomes 1 unit less. Is that understandable? And then, of course, nobody writes 7 minus 1. There is a better name for that. What is that? It's 6. So the derivative of this is called 7x to the 6. Now I want to talk what is the meaning of differentiation. This is absent in Swedish text. Okay? The final product is called derivative. The process of going from a function to its derivative is called differentiation. Okay, so let me write this one. This word I will use it. Don't say that I don't know English. I'm just teaching you this English word. Okay, it's not in the book. I don't know why. How in Swedish? How do you say differentiation? But this is the case. Function. If you have a function, differentiation is the process that I am doing. If someone asks me what I am doing here, I said that I'm differentiating this function. And if somebody tells me what is this one, then I would say this is its derivative. Yes? And that's exactly the English word. The meaning of derivative means what you get from something. Yes? So, and that's not the process you reach to that. Yes?
In the book, On page 86, there's a translation in the box.
So can you just...
De Riviera.
Okay, but the Riviera is more or less coming from... So what is the translation of differentiation in Swedish? So I mean the Riviera... Pardon? So the Riviera is probably for me, the Riviera and derivative are coming from the same root. But in English, differentiation is coming from a different root than derivative. Yes. Anyway, if you read an English book, you will see this. They might say that find the derivatives of the following functions, or you can say differentiate the following functions. Yes. So both of them mean the same. Mean the same. So function differentiation, and then the final product is called derivative. So differentiation is the process to go from the function to its derivative. The final product is called the derivative. So if I ask you, by the way, look, I started with a function x to the 7. I ended up with another function. So derivative is another function which is derived from the original function. Okay, so that's why we call it derivative. Okay? Okay, this is the case. Now let us go to number 2. So let me write f of x. By the way, I don't need to keep the name all the time f. Let me change it to g of x. Let me ask you, how do you calculate this? X to power pi. Okay. Can I use the rule for this? I would say that, okay, that's that's a power. The base is exactly x, nothing else. And the exponent is a constant, because pi is 3.14 something, etc. That's a constant. So can I use the rule? The answer is yes. So what would be the derivative? Pi goes down, and then you write x to power pi minus 1, nothing else. You're not allowed to put 3.14 or something. You have to keep it in this exact form. That is the answer. Is that clear? Okay. Let me ask you this question. For example, s of x, let me call it, I don't know, third root of x to the 2. I want to find the derivative of this function. Once you immediately see that it is not exactly in my table. So as a math student, actually your goal, your duty is to change the form of the given function in a form that you can find it in your table or you have it in your memory. Okay, so this is not exactly here. Do you see this appears in this column? No. So it means that you have to use your previous math knowledge to change the form of this function into a form that you can see it there. That's the only duty that you have. So it means that you need your previous math knowledge. So I need to write this again. So what is another name for a square root? So let me get rid of this one as well. So what is another name for a square root of a? A to power 1 over 2. If I do, so by the way, you know that if I don't write something here, it means that it is 2. If it is not 2, if it is n, then what?
A to the power 1 divided by
1 over n. These two are in the formula sheet, okay? But let me complete it, n, and let me have a to power m. Okay, then what? So you don't need to memorize that. You can feel it in this way. If m is an integer, for example, what can I write? I can write it as a times m times, and then you can write this, I don't know, and then this, and then you can write a to power 1 over n, times a to power 1 over n times a to power 1 over n. Then you can add them, yes? So then it becomes 1 over n plus 1 over n plus 1 over n m times. So it becomes m over n. Okay? So it's not hard. But let me just write it. We don't have time for that. These are the previous lessons. So I want you to write it somewhere because it is very, very important for the notion of derivative. Okay, so now you see that you don't have any problem. If I want to calculate the derivative of this function, if I want to differentiate this function, which formula is suitable here? The last one. Yes? So what can I write? First, I need to be patient to change the form of my function. Okay, help me to write it. What is this? X to power? X to power?
2 over 3.
2 over 3, thank you. And then here, now I can take the derivative. So now we can take the derivative. Take the derivative is a wrong word. I learned to use it here in Sweden. We have to differentiate it, okay? So S prime of x is equal to. So 2 over 3 goes down, yes? And then I have x to power 2 over 3 minus 1. Is that understandable for everyone? So you see, only this part is the new lesson. So this is why I'm saying in mathematics you really need to remember. Going from here to here is a Math 2C problem. Going from here to here is this new lesson. And again, the rest of it is your previous knowledge. You need to be able to simplify this as much as possible. So what can I do? I don't know. Hopefully you don't have any problem in calculating this, yes? 2 over 3, you have to keep it in fraction form, exact form. Of course, if the exponent is 1 over 2, you write 0.5, that's okay. But if the exponent is 1 over 3, you write this. This is an approximation, that's not okay. You have to answer exact form, okay? So, can you tell me what's the answer in your head? 2 over 3 minus 1. Negative 1 over 3, yes? If you have problems, please let me know. For the time being, I don't have any problem if you stop there. Okay, that's the problem. That's finished. But I myself prefer to simplify it a little bit more. Okay, so okay to stop here, but if I want to make it better, yes? So beauty is actually a very important thing in mathematics, yes? So this is 1 over 3. And then what can I, even 1 over 3, I don't like it, yes? What do you prefer to write instead of x to the 1 over 3? The third root. It's more beautiful, don't you think so? The reason that's more beautiful because it's more familiar. Yes, might be, that's the case, we don't know. Okay, but I myself prefer to stop there. For the first part of the lesson, it is not that important that you can simplify because I want to focus on your skills in differentiating. But if you want to go further and further, if you are not able to simplify your products, your derivatives, then you will be in trouble to solve the rest of the problem. Because that's just one part of the problem. You take it, you differentiate, and then you find something else. Is that clear? So be careful. 2 examples, 3 examples here. Let me make it a little bit harder. Number 4. What do you think about this situation? Let me make it k of x, another function. Let me write it as x to power 2 okay, this is not a good way of writing, but let me just test your understanding. X to the 2 times x to the 3. I want to take the derivative of this function. Okay? So let me write. What is the derivative of x squared? Just tell me quickly. The pattern is there. What is the answer? Just tell me. 2x. Just tell me. Okay, it's good. And then what is the derivative of x to the 3? What? 3x squared. If you write this, for this is wrong. I just want to, because I have some experience, I don't know, for some reason students think that they can do something like this. They would say that, okay, I take the derivative of this part and take the derivative of this part and just multiply them. Who says that? Yes? You are inventing new rules. If you are inventing new rules, you need to prove them in mathematics. So you are saying that if I have a product of two functions, if you say this is correct, this is based on my experience, people feel this. Okay, if you're saying that this is correct, this is wrong, I want to mention that. Why? Because here I am saying, I am implicitly using a rule which is not clear yet at all. I am saying that I can, for a product, I am allowed to take the derivative of this part, the derivative of that part, and multiply them. Okay? Even if this is true, we haven't studied that yet, but trust me, this is not true. Yes.
Can't you just simplify it?
Yeah, exactly. Yeah, that's the reason that I wanted to bring this up. If I give you this, of course I will never give you this. I should be stupid to write x2 times x to the 3, because there is a better name, that's x to the 5, okay? But there is a point for this one. Okay, so if I want to do this, the first step that I need to do was what? Write x to the 5, and then take the derivative. What is the answer?
5x. 4.
As simple as that. But now, why I told you this? Because I wanted to prepare you for this example. So let me 5. So let me call the function L of x. Let me write x times x square root of x. And now I want to take the differentiate this function. Yes, I need to say differentiate. I want to differentiate this function and find the derivative. So I hope that you are not writing 1 times this. Do you remember now? Yes? Because you have the formula for the x itself to be 1. You have the formula for a square root of x to be that guy. But if you write 1 times that is wrong. Yes? So I want to wait a little bit for you. You can just do it yourself. And by the way, let me write some more here for you. So for example, r of x is equal to that's good. So let me write x to the 2, the 5th root of x to the 3. Yes, I want to wait for you to do these 2 things. So this type of questions mainly you will get in exam. A function is given to you, you're supposed to find the derivative not from using those limit process. This limit process would be also in the exam, but mainly you need to know how to differentiate functions according to the rules. Okay, so here, I don't know what is this is working. So what we need to do, we need to simplify this expression. Let me change my color not to mix it here. So if I want to do this, the first step, I see a function, I am supposed to differentiate it. This is not in my table, so the only way that I need to do is to change the form of this function so that it matches with one of those formulas. Yes? So that's my duty. It's not hard. So I will write it x. This is x to the power of 1 over 2. So this is not the new lesson. This is Math 2C lesson that I am writing it in that way. Again, it is not finished. I know that this power is 1. This is 1 over 2. So this is again Math 1C lesson that I can add them. And then this is still a primary school lesson. So this becomes 3 over 2. Okay? If you continue, you will go back from the first grade. Okay, so 3 over 2. And now the new lesson starts, because now x to the power of 3 over 2 has this form. If I ask you what is playing the role of this c, you would say 3 over 2, yes? So what I can do, I can say L prime of x is equal to 3 over 2 goes down, and then x to the power of 3 over 2 minus 1. But 3 over 2 minus 1, what's the number? X to the power of 1 over 2. If you stop here, that's completely okay for the time being, but I myself prefer to continue and write it as square root of x. Either you can stop here or there, so that's the correct answer. Is that understandable? Okay. The next problem. The next problem is simplify this again. So Rx is equal to. Can I start differentiating immediately? No, because I don't have any information in my table for this function. So I need to change the form. So you see I'm repeating it over and over again. So this becomes x to the 2 multiply. This one I use this formula. So I would write x. You see the one which is here goes to the numerator. The one which is here goes to the denominator. So what happens here? It becomes 3 over 5. And then again, I have this one plus that one. If you don't understand this, please let me know. Okay? 2 plus 3 over 5 is 13 over 5. Agree? Because another name for 10, another name for 2 is 10 over 5. 10 over 5 plus 3 over 5 is 13 over 5. Is that right? Now, everything is in order. I start differentiation. R prime of x is equal. 13 over 5 goes down. So it is 2.6 that you said, that's right. And then x to the power of 13 over 5 minus 1. Yes? So then it becomes 13 over 5, x to the power of 8 over 5. That is good if you want to keep it here, but let me just do the process a little bit for you. I myself prefer to continue and write it as the fifth root of x to the power 8. Still, I don't want to stop there. What I do, I would write 3 over 5, the fifth root, x to the 5, x to the 3, but the x to the 5 and this one will be cancelled, so 1x will go out. This I want you to learn, especially those who want to actually be continuing somehow in mathematics in the future. But this is optional for the time being. This one is correct answer for me. I myself prefer to go up to this point. Okay? Any questions? I know that I have talked a lot, but I still want to continue. One thing that is important. Now let me ask you one question. This is a little bit motivating question. Any questions so far? Okay, so what happens if I ask you this question? F of x is equal to x to the 5x to the 3. I want to ask you to take the derivative of this function. What do you say? Assuming that your mathematics is excellent, how do you answer this question? Let me ask you this question. If I don't have this 5 here, is that hard?
No.
It is 3x squared. Now I have this 5 here. What is the answer? The good answer here is silence. It's good. Because at least if you say something and it is wrong, it's not good. But if you are keeping silent, it means that you understand that this is not in my table. Even though the changes is not that big. I'm just multiplying it by 5. It turns out to be, but it needs reason. It turns out to be that this 5 doesn't play any role. You can just simply, in the beginning, you can just ignore that and take the derivative of this, which is 3x squared, and then multiply it by 5. Okay? The way that book is doing it is this, that just cheating, yes? This is not good, because we can understand why this is the case. Another question. If I give you this function, what is the answer to the derivative of this function? If I ask you the derivative of this, you know. If I ask you the derivative of this, you know. But now this is, unfortunately, this is combined of two very familiar functions, but this is a new function. And if I ask you what is the derivative of this, it is not clear unless you have already studied that. If you haven't studied that and you say 5x4 plus 3x3, 3x2, unfortunately this is the correct answer. But you need to understand this is not trivial. Yes? It is not that trivial at all. Why? If I multiply my function by a number, the derivative is multiplied by that number. It's not clear. Why? If I have two functions added together, the derivative is the sum of the individual derivatives. That's not trivial, even though the book hasn't mentioned it at all. They are using it as if it is trivial. No, it's not trivial at all. Okay, so I want to write them here for you. So let me see. Am I finished the book? Yes, I have finished everything which was related to this, but your book has just written a formula for this without understanding why. Okay, so let me write some formulas here for you. These are general formulas. These are also given in the formula sheet, but let me tell you, if I have a function f, which is, I will talk about the reason why these are correct next time, okay? But for the solving these problems, you need to know these rules. If I have a function, and if c is a constant, and if I multiply my function by that constant, and I want to take I want to differentiate the new one, the rule is this. It turns out to be, I need to motivate why this is correct. You don't need to care about c. You take the derivative of your function and multiply it by c. This is one rule we will talk about. This is not trivial. The way that book is dealing is, it seems that it is trivial. No, not at all. Okay? And then f plus g, if I have two functions, if I add them, and now I am interested to differentiate this new function, then it becomes the derivative of the first one, the derivative of the second one added. Okay? And if I have the same for the difference between two functions, it turns out to be f prime minus g prime. But please do not draw this analogy further. Because if I say you f multiplied by g, take the derivative. If you say that, okay, I take the derivative of the first one, the derivative of the second one, and multiply them, that is wrong. These three formulas is at math level, math 3C level. This formula is a math 4 problem. So that's called the product rule. And there is another formula for the quotient rule. We will talk about them in math 4. If I have the quotient, if I have a fraction, and I want to take the derivative, I am not allowed to take the derivative of the numerator and the denominator separately. That's also wrong. Okay? So these are math 4 problems. But these are at the level of math 3C, even though the book is using it over and over again without mentioning it. As if it is trivial. No, it's not trivial. Okay? So I want you to know. So if I ask you, find the derivative of this one, you now can answer that. How do you answer? You say that 5 is multiplied by this. The 5 is this constant. So it means that for the time being, I write my 5, and I concentrate on taking the derivative of this, which is 3x squared by the formula in the table. Then 5 times 3 becomes 15x squared. So the derivative of this function is 15x squared, but I will give you the reason why these formulas are correct next time. But now, can you tell me what is the derivative of this? So which rule is that? If I want to name them, this is rule number 1, 2, 3. Here I have used rule number 1. Yes? So which rule I can use here to calculate the derivative of this? It becomes the derivative of the first part plus the derivative of the second part. So this is rule number 2. But the derivative of the first part is in my table. The answer is 5x to the 4. The derivative of the second one is also in my table. It's 3x to the 2. Okay? So for the time being, take these for granted, but I will prove them for you why these formulas are correct. Okay? Is that clear? So let me just give you one more and then we are done. For example, I have 5x to the power of 3 minus 10x to the power of 11 plus 11. I want to take the derivative of this function. So let me do it patiently. I need to, you see, I have the difference and the sum of functions. Okay, so what will happen? It becomes the derivative of the first one minus the derivative. Let me stop here. Okay, I don't want to confuse. Let me stop here. You can think about this yourself, of course, this is not hard. But now, if you want to be on the safe side, please read pages 86 to 88. You see that that's exactly what I have described here for you. And then please try to solve problems on page 89. Okay, so I will write them on a school stuff again. Thank you.